Okay, hi, in this video we're going to talk about recursion, how is it used, and how to compare it with loops, when it's convenient to use loops as while before, or when to use recursion. Recursion is a very useful tool, forgive that, in C++, as it allows a function to call itself and repeat continuously, just as a loop, but the structure is different and it's convenient to use recursion in other times. It may sound confusing for a function to call the function within it. For example, we're going to take a very simple example that I created here. A void, it returns no value, which name is count, we use an integer n as a parameter. If, then we give is greater than 0, it will do the following. It will cout n, it print it, and then he's going to do again count, but with n minus 1. For say, if I put 5, it will put 5, print 5, return, but with 4, and then start. As 4 is greater than 0, it will print 4, return, it will 4 minus 1, 3, as it keeps going, it's greater than 0, and on, until it gets to 0. And else, so when it gets to 0, cout done. Okay, this is gonna be like a countdown. And for example, here I'm gonna close this so you don't get confused. In my main, I just declare my n, ask for the n, from how many numbers you want to count down, and we then use cout since it's not a value. It returns no value, and it's just a recursion function. So for example, here we're gonna compile it first. You can see no errors, and then we're gonna execute it. Okay, here is asking for how many count. I'll say 10. I say 10. Okay, let me 10, 9, 8, 7, up to 1, and when it comes to 0, it says done. For example, we're gonna execute it again, and for example, if I were to write minus 1, it will be done because it is less than 0. So here, for example, we have to make a specification, for example, so we can write here, like, I don't know, cout give me a positive number, dude. Now, with that, we can conclude that the user can give us a positive number, and we use it. Okay, now we're gonna compile it again in here, and no errors. Run it, give me a positive number, dude. I don't know, h. Count from 8 to 0, done. And for example, when is this convenient and when are loops convenient? You see, this structure is pretty simple as it uses small values, but for bigger operations and bigger functions, loops may be more convenient. I mean, for example, in Fibonacci rule, the one that adds the last two numbers, like would be 1, 1, 2, 3, 5, and keep going and keep going and keep going. If you use recursion, you have to put like Fibonacci of the last number, it will be the Fibonacci of the last two numbers. So we will continue using Fibonacci at the last one. And to use these ones, you will have to get the two previous ones. So it will be keep going and going and going. So imagine if you do the Fibonacci of 20, you will do the Fibonacci from 20 to 0, each and every one of them at least 2 times. So you may run out of memory and it becomes very slow and recursion. But for example, if you do it with loops, it becomes very useful since it just stores the last 2 values, which you can add up, and with 3 variables, you can obtain the Fibonacci of a bigger number by using a fair amount of less memory. For example, in the practice of drawing triangles with strings, it is also possible via loop or recursion. By practice, you may notice which one method is convenient for you to use at once or at the other. Thanks for watching.